Assalamu alaikum everyone. Today you will be learning what functions are, so let's jump right into it. A function is a relation or a connection between two quantities such that every input has exactly one output. Now, to understand what a function is, you have to understand what a relation is, and I'll underline it. We have to know what a relation is. So, a relation is basically a connection between two numbers. Okay, whenever two numbers are connected or related to each other, we call that a relation. Now, I'll give you some examples of a relation. Let's say that your age and your height, both of these quantities or numbers. Your age is a number. Let's say you're 14 years old, and your height is also a number. Let's say you're 6 foot tall. So these two numbers are related because when you were a baby you were shorter. Now that you've grown up, now you're taller, and so these numbers are connected. A relation clearly exists between them. Another example would be your age and your weight, right? And another example would be a more mathematical example would be the area of a circle and the radius. Well, obviously, if you take the radius to be bigger, the area of the circle is going to be bigger, and if the radius is smaller, the area is going to be smaller as well. And so these two quantities, these two numbers are related to each other. Okay, now let's say you go to a store and you want to buy some chocolates. um, so let's say that you can get y number of chocolates for x dollars, right? Because you're not getting anything for rupees. So you can get y chocolates for x dollars. Now, as you can see, the amount of chocolates, the number of chocolates that you can get is dependent on how many dollars you have. The amount of chocolates that you can get is dependent on x. Y is dependent on x here. And now, um, in mathematical language, the way we write this, or the way we understand it, is we call this as a function. Well, if y is dependent on x, if one quantity is dependent on the other quantity, if two quantities are related, okay, if two quantities are related to each other and one of them is dependent on the other, well, we call that a function. Well, y is dependent on x can be written as y is a function of x. And I'll tell you the notation for it. Function notation. We write this as y equals f of x. F, well, the way we read it is y equals f of x. And now the f here, this one, this is the name of the function. I chose an F because the word function starts with an F. You can literally choose any letter you want. This X here is the input or the money in this example, and this Y is our output or our number of chocolates. Okay. Okay, so this is basically how you write functions. Now let's say you can get two chocolates for each dollar. So the function that you'll get is y equals to x. Okay, and I'll show you why it is that way. Because let's say if you've got $1, okay, I just wrote one instead of x. If you've got $1, you can get two chocolates, right? The way we write it is, if we have $1, we can get two chocolates. Right now, instead of writing this whole sentence, we can simply use function notation. And the way we write it is like y equals f of x. Y is a function of x, and y equals 2x as well. Okay, y equals 2x is a function because y and x are connected through this equation, right? And y is clearly dependent on x because we're inputting a value into x, which is going to be multiplied by 2, and then you're going to get the value of y. So clearly y is a function of x and y equals 2 of x. So we write it as f of x equals 2x. Okay, and when we want to input any number, for instance we're inputting the amount of dollars. Let's say I've got $10. Okay, now this is how we write. We're basically substituting x for 10. We're writing this value this value in place of 10. I'll show you how. This is what we're basically doing, and we're getting 20 chocolates for um, $10. That's basic function notation. Okay, now a function can also be represented by a machine. People also call that it is similar to machine. It works similarly as a machine, and I'll draw that for you. Okay, this is a bad drawing. Okay, perfect. Now we've got our machine over here. We've got our function, or we can call it a machine, which basically processes different inputs and gives us outputs. Okay, you input some value in it, and it's going to give you the output. Right, you can think of it as a juice maker. You put in mangoes and milk and sugar, and you're gonna get milkshake out of it. Okay, so this is basically what a function is. Now let's say the function was 2x plus 7, for instance. Now if we input the number 7, let's say, and now what's going to happen is, what we basically did was, the function is y equals 2x plus 7, right? And it is equal to f of x, because it is a function. So what we're doing is we're inputting 7 inside this function f, right? We're putting it inside this function. We're putting this inside this function. What's going to happen is, it is going the x is going to be substituted by this input, which is 7, and then we're going to add 7, and we're going to get 2 times 7 is 14, plus 7 is 21 as the output. Okay, so f of 7 is going to be equal to 21. Okay, so now you guys know what a function is. Let's draw some graphs to see what is actually going on here. Let's draw a graph. Let's take a function, let's say 2x plus 3. Okay, now I'll draw a graph for it real quick. Okay, so this is our graph for y equals 2x plus 3. This y-intercept is going to be 3. You guys don't need to understand why that is 3. We'll discuss it. We'll learn all of that in coordinate geometry, in ADMATS, and in AS level as well, and you might have studied it in your O levels. Okay, so well, why did I make this graph? It was the reason for this was to show you, to to make you guys able to identify if some equation is actually a function or not. And how do we see that? The way is, you're gonna look at some inputs. Okay, I just took 4 inputs, 4 values of x, and we're gonna look at the corresponding value of y. Okay, and what we see here is that this input has exactly one output. Okay, and this has one output, and this has one output, and this has one output. Okay, oops, this has one output. Okay, and as I defined functions in the start, what is a function? A function is a relation or a connection between two quantities or two numbers. We understood that part. Now the next part was, every single input must have exactly one output, and this is what I mean by that. Every value of x should give you only one value of y. There shouldn't be two outputs, right? So this graph is clearly a function. Now there's also a test that we used to see if something is a function or not. We call that the vertical line test. You can basically use your ruler or your pencil or pen to slide it across the graph and check if this line, if this straight line cuts the graph at any 2 points. If it doesn't cut at 2 points, if it cuts at only 1 point, then it's obviously a function, and if it cuts at more than 1 point, then it is not a function. Okay, now let's take another example. Let's take a quadratic. Now y equals x squared. This is our equation. Let's draw a quick graph for it. Okay. Okay, so here's our graph for y equals x. But now you'll realize the same thing. Let me bring my line over here, and instead of, you can use these points as inputs, and you can check that there's only one output. But I'll just use a straight line to show you guys that this straight line is cutting this graph at only one point. Okay, across the whole graph, it's only cutting it at one point. So this is clearly a function. Let's take another example. Let's say we've got y squared equals x. Okay, I'll draw the graph for that. Okay, this isn't a straight line. Okay, okay, so it looks something like this. Wow, that was perfect. Okay, so as you guys can already see that this is not a function, and why is that? Because let me bring my straight line over here. What's happening over here? Well, let's take an input. Well, you saw it on the graph that this line is cutting the graph at 2 points, and so this is not going to be a function. But let's see what that means, mathematically. Um, let's take this input. Let's say this is 4, and let's input it inside this equation. Y squared equals 4. Now if you take the square root on both sides, what are you going to get? Y equals positive and negative 2. Well, this is positive 2, and this is going to be a negative 2 right here. Okay, and as you guys can see that these are two outputs, and the way we defined a function was a function. In a function, you can only get one output for every single input. You must have one and only one output. Now we know that this is not a function, but look at this point right here. This point has only one output, and so do we consider this as a function then? No, we're not going to consider this as a function. The reason is that I told you guys, and I wrote it in a different color, is because every single input must have exactly one output, and so this is not a function. Let's draw another graph to cement your concepts. Okay, we're gonna draw a beautiful circle. Obviously this app is going to do that for me. This is our circle right here. Okay, let's bring it. Okay, perfect. Now this is our circle, and the equation for this circle is x squared plus y squared equals 1. Will You don't need to know where this equation came from yet, because we'll study this in the chapter where we learn circles. Okay, so for now, let's look at the graph, and what we can see is that this is our point 1, this is negative 1, 1, and negative 1, and you'll understand all of this later. But for now, let's just use our vertical line. Let me bring it down here. Okay, slide it across the graph, and you guys can see it is cutting the the graph at 2 points. So this is not going to be a function, and this point is special. This point and this point is special. Why? Because you know in this input you're getting only one output, right? But as I defined, that every single input must have only one output. So because all of these points, these have two outputs, we're going to we're not going to consider those 2 points. Okay, so what happens when we input a number inside this equation? Let's say x is 0.5. So 0.5 squared plus y squared equals 1. Well, what's the square of 0.5? It's 0.25 plus y squared equals 1. Now y squared equals, if you subtract 0.25 on both sides, you'll get 0.75. Now if you take the square root, you're gonna get some number. Let me find my calculator real fast. Okay, so you'll get the number 0.866, a positive and negative of that. And as you guys can see, it is giving us two outputs right here, right? And for that reason, this is not going to be a function. Now you guys know what a function is and you know what a function isn't. Let's do some quick and small questions to kind of do a little bit of practice of inputting function, because that's what you'll be tested on in your exam. Let's say we've got a function f of x equals 2x plus 3, and we've got another function g of x equals x squared plus 3. Yeah. Okay, so now let's do a set of questions. Okay, part A, we're gonna find out what f of 2 is. Okay, so what we're doing is we're inputting 2, we're putting it in the place of x, as you guys can see. So what is 2 times 2? It's 4 plus 3 equals 7. That's it. Now let's input another number. Let's input the number 69. Okay, so 2 times 69, what's that equal to? 138 plus 3 is 141. Okay, so that's how we input different numbers. Okay, now let's take a look at this function. Okay, um, g of, let's say we've got g of 10. Okay, so we're gonna input 10, we're gonna take the square of it. We just input 10, we are just putting 10 in the place of x. So x was being squared, so we squared 10 over here. If it was x cube, we would have taken the cube of 10. Okay, and the rest is going to be the same. 100 plus 3 is 103. Now let's say you have to input some variable into it. What are you going to do then? You're basically going to do, you're going to take, you're going to put it in the place of x, you're going to square that and do the rest. Y squared plus 3, it's just as simple as that. There's nothing, literally nothing difficult in this topic. Okay, now let's say x, no, not x, let's take, okay, let's actually take x minus 3. We're inputting that. So now in place of x, what we're gonna do is we're gonna put x minus 3. So it's going to become x minus 3 whole squared plus 3. Okay, so that's it for today's video. I hope you all understood all the concepts, and it was a fun lecture. I'll see you all in the next lecture where we'll be discussing some more important concepts. So see you all guys in the next video. Take care. Bye bye.